Hello, and thank you for joining us today. It's a pleasure to welcome you to this webinar organized by Innovise on how the city of Scottsdale leveraged sensor data to streamline water distribution system analytics with Innovise's new cloud platform. My name is Cristina Novo, and I am technical editor of Smart Water magazine. Based in Portland, Oregon, Innovise is a global leader in water infrastructure software. For 35 years, Innovise has been building innovative software for the water industry and is trusted by approximately 3,000 customers worldwide, including utility companies in many of the most populous cities across 5 continents, a majority of ENR's top design firms, and leading environmental and engineering consultancies. Innovise's modeling, simulation, and predictive analysis solutions enable more cost-effective and sustainably designed water distribution networks, water collection systems, water and wastewater treatment plants, and flood protection systems. Further, Innovise's solutions centralize infrastructure asset visibility to optimize capital and operational expenses. Earlier this year, Autodesk announced the acquisition of Innovise, a move that creates a clearer path to a more sustainable and digitized water industry. In today's webinar, Innovise will show how utility can transform its hydraulic model planning into a real-time operational solution. We will also hear about a case study focused on the city of Scottsdale's use of Info360 Insight and InfoWater Pro as an enterprise platform to increase efficiencies in managing their water distribution network. We have 2 speakers. First, John Crochet, Regional Sales Manager at Innovise, will present the company's software solutions. In the second part of the webinar, Nathan Gertz, Product Manager, will present the Scottsdale case study. At the end, there will be a question and answer session. You can send us your questions using the Q&A function in Zoom. Please identify yourself and your organization of affiliation when you send your questions. Feel free to send them through the session as they occur to you, and we will address them at the end. The webinar should last about 1 hour in total. We would also like you to share your thoughts with us on social media using the hashtag #KeepInnovising. And now I would like to introduce the first speaker. John Crochet has more than 8 years of experience in water distribution, sanitary sewer, and environmental engineering with a specific focus on computer-based modeling applications. He received a BS in civil engineering from Clemson University before working for mid-sized engineering consulting firms in Charleston and Denver. He joined Innovise in 2019 as a systems engineer before moving into his role as regional sales manager for the Mountain West region. As a team leader, he is responsible for the promotion, organization, and delivery of industry-leading GIS-integrated smart city software solutions. He will be talking about Innovise's software solutions. Welcome, John, and the floor is yours.
Before we get started, I skipped an intro slide, but I do want to thank the city of Scottsdale real quick. I'm the account manager for Scottsdale, so really just want to thank everyone that was involved from the city, all the way from the engineering team. I got to work with Scott Anderson the most, to, of course, the IT folks, Sam Adams and Jason Brailsford team, that really want to say thank you to the entire city of Scottsdale for working with them on this project and also allowing us to feature them with this presentation. So want to start off with that, and also want to just mention that we are not showing any of Scottsdale's data specifically. So Nathan will be going through the software and some screenshots, but just want to preface that we're not showing any quote unquote live data or SCADA data directly from their system. But thanks everyone for joining today. Again, we'll be talking about really our new cloud platform and Info360, our new enterprise platform, with a focus on our first application in Info360 Insight. But for those of you who are not familiar with Innovise as a company, This is just a quick slide, a little bit about us. As Christina mentioned, we are a global company. So we're in, the top 6 of the 7 major continents. We are a global company with offices in the UK and Australia. Nathan and I are both here in the United States, as Christina mentioned, so we help support our client base here in the United States. But the most important thing, as Christina mentioned, is maybe the little emblem that's added under our logo now in Autodesk. So we are a part of Autodesk now. Personally, I used a lot of Autodesk products in my consulting days, and I'm honestly thrilled about what I think is a kind of a final home for Innovyze here. And I think it's a great fit considering our product lines don't really overlap. And I think it's a good opportunity for Autodesk and Innovyze to kind of build out, that portfolio all the way from the design phase through the construction phase as well. And so just real quick, for those of you who are not terribly familiar with Innovyze, this is just a brief overview of the product lines, I guess, or solutions that we offer. So a lot of folks are probably mostly familiar with these first two in terms of our hydraulic modeling solutions. So those are the InfoSwim users of the world, the ICM users of the world, the InfoWorks WS and InfoWater Pro users of the world. So I think most folks on the call are probably pretty familiar with our modeling solutions that, of course, have been used for decades. But what we're really focused on with our new cloud-based platform, and that is Info360, is some of the, I would say, more live data, more robust solutions in terms of the data that we're bringing in to actually run a simulation or run an analysis. So with asset management and operational analytics, there's a lot of work order data, a lot of SCADA data, a lot of meter data. There's a lot of data sources that we're collecting for our asset management and operational analytics solutions. So that's where we decided at Innovyze it was time to kind of transform really our product line. So at the highest level, I guess for the folks on the call, the point I want to kind of drive across here in terms of the entire platform is we want to have an enterprise platform that is really open to anybody your utility to use. So if it's an operator, if it's an engineer, if it's a manager, if it's someone in the field, if it's your consultant, for example, we really want to be able to house all of that live data that I was just referencing in a platform that is able to process it efficiently, and it's able to do analytics on it. And then in turn, you can bring any of those data points and any of those analytics into our desktop modeling solutions as well. So that's really the idea with our cloud platform. It's an online platform. So again, it's really meant to be used by anybody in your organization. But really the benefit from my standpoint or from an engineering standpoint is you can bring in, any of those data points that are being processed. So you're processing the raw data, in this case, SCADA data with Insight. You can bring that into the model and utilize it for planning and engineering. So that's really where we got this title from in terms of bridging the gap. A lot of our customers, it's been a linear relationship, I would say, where, live data or something comes in through your SCADA system. You have an operations team that might utilize that on a daily basis, but it doesn't really get opened up and utilized throughout the entire organization. So that's really, really what we're trying to get at with this platform. It's an enterprise platform that opens up the live analytics and really, all the data that you're collecting as a utility. And this is just another visual kind of showing what I just went through there. But just to kind of recap again, Info360 is the online platform. So Info360 is the platform, and there will be different applications. The application we're focused on today is called Info360 Insight. So that is an operational analytics application that basically hooks up to your distribution system SCADA system, any meter data, any of that live data that's being collected on your distribution system. That's really what we're going to focus on today. I'm not going to focus on some of the other applications of this platform, but there is, you'll be seeing a lot more from Innovyze in terms of Info360 Asset. So not many people have heard of that application yet. But that's really the next application of this platform. That's our asset management application for our Info360 platform. And then real quick, just to talk about some key features with Info360 Insight specifically. So again, we're talking about one application of the Info360 platform. But Info360 Insight is, again, the really distribution system application that hooks up to your SCADA system, hooks up to consumption data. It can hook up to really any live data source that's being collected on your distribution system. And some of the benefits listed here in terms of Info360 Insight, really a lot of folks have a SCADA system and SCADA software that's associated with that. So that's one kind of clear differentiator here that I want to kind of hit on is we are really doing a lot of analytics and processing of that data. So we store your data in certain time intervals so that we can do a lot of really cool analytics that Nathan's going to talk about in terms of water loss and like break detections and stuff like that. So that's where, when we store your data in a very clean time series format, we can start to perform a lot of different analytics and build different dashboards that really, we can look at the performance of the system and track the performance of the system over time. There's a lot of different analytical tools I mentioned, like a mass, we basically break out each pressure zone into a mass balance equation. And then that way we can build on it with different analytics from water loss to, again, break and leak detections and things like that. One thing I do want to hit on real quick is the hydraulic model integration. So for those of y'all that are InfoWater Pro or InfoWater users, that's one of the main benefits of this platform as well is, again, we're not bringing in raw data into our hydraulic models. We're bringing in process data. So we can bring in our diagonal curves, pump curves, any of those data points that you need to calibrate or keep your model up to date. Those are all things that can be incorporated into Info360 Insight that you can bring them into your model as well. And I won't focus too much on the bottom left because I want to give Nathan the opportunity to highlight those in the software as well. But really at the highest level, the platform does offer the opportunity to really open it up for your operations folks as well. So there is a new tool called the incident management tool. That's really exactly as it sounds, an incident management tool where if an asset goes offline or you have a break or a leak, you can look at different scenarios or different ways to address the problem using the hydraulic engine that's within the Info360 platform. So Nathan will touch a little bit on that and within the platform and how it's being used at Scottsdale. But with that, I do want to turn it over to Nathan now so that he can talk about a little bit about how we're using this platform over at the city of Scottsdale. Well, I guess I'll give it to you, Christina, first. I'm sorry to give an introduction for Nathan.
Thank you for presenting the Info360 platform and introducing this first application, Info360 Insight, and its key features and benefits. If you have any questions for John, please forward them using the Q&A function in Zoom, and he can address them during the question period at the end of the webinar. We're now going to turn to Nathan Gertz, product manager at Innovise. Nathan Gertz is the product manager of water distribution solutions at Innovise, helping guide development to lead the market of hydraulic modeling software for water utilities. Nathan has worked for Innovise for 6 years, helping from project implementation and support to pre-sale support and solution scoping. As John has mentioned, he's going to be talking about a case study in the city of Scottsdale in Arizona. Welcome, Nathan. Please go ahead.
There we go. So my screen should be up now. So yeah, thank you for passing that along. So I'm going to talk through a little bit of our implementation with Scottsdale and talk about some of the features that they are choosing to use within Info360. So just a really quick high level about City of Scottsdale, some statistics. Well, it's a suburb within the Phoenix metro area. So it kind of looks like this within our map dashboard. There's a number of statistics. I won't bother reading all of these off, but two numbers I do want to draw attention to is that it is a lot of elevation. So there's 2,600 feet of elevation variation within here. So there's a lot of hills up here that results in a large number of pressure zones, 149 different pressure zones throughout this system that then ends up necessitating a large number of control valves and pumps. So that's their system at a high level, and some of their objectives coming from that is that they want to have dashboards where they could manage the pressure, to review pressures throughout the system, get a quick understanding of pressure variations, have alerts on demand of pressure exceedance instances. In addition, their system is broken into 4 separate zone or areas, and so we are doing mass balance, which basically just sums up the volume being used by each isolatable area, and I'll highlight which areas we can isolate, since this is not a full DMA system like some of our other global users. So mass balance analytics I'll be getting into. Also, with a number of their pumps, they are going to be using some of our pump efficiency analytics and reporting. So I'll show that. And then finally, one of the big drivers of this project was model integration. So because we are being able to tap into their SCADA data, we can connect that to the model to really streamline model updates, even use the model for operational understanding. So those are some high-level objectives that I'll be stepping through. As far as the actual project, what that project looks like, we start off with a project kickoff to outline the different timelines and deliverables that we will be working on with them. We define the system. So we actually deploy a data ingester, is what we call it. So Info360 itself is completely a cloud solution hosted on it, in the cloud by Innovyze. And so we have a software component on site that pulls their SCADA data in real time and uploads it to our cloud. I'll come back to that in the next slide. So we import the full sensors and system definitions. We also upload the model to get the web maps set up. So that's the step 2. Step 3 is we actually deploy. So we configure all of the different sensors in their system. We define the pressure zones or DMAs, depending on what you have. And we associate each of those sensors or processed sensors with model elements. And then finally, the actual build phase, and this is where we're still at with Scottsdale, is building custom workspaces, continuing to roll out the analytics for them. And throughout this process, the user has full access to log in, access the site, play around, customize their own dashboards, give us feedback on the dashboards that we're building with them. And so we're kind of at this interactive build phase with them. So that's just a quick look at what the project looks like. One detail, this was the one piece where we have to work directly with Scottsdale IT and ensure security compliance. I know that security is a really high, it's a growing concern among many utilities with recent breaches, but not of our software, but just globally. So what happens is Innovyze deploys a data ingester on premise. It gets read-only access credentials to the SCADA historian. And in many cases, we don't actually connect to a historian. In many cases, there will be actually like a SQL server or some mirror of the historian where the data is replicated, and then we pull from that with read-only access. And then we use full secure AWS encryption from that on-site location into Info360, where it remains encrypted and locked behind a number of secure credentials. And so this was a key process of that starting phase. And that is that piece. And yes, that's a quick note on that. So then finally, once we have the site set up, we deploy different dashboards. So this is just a quick GIF showing that we have 4 different dashboards highlighting different aspects of the data. So this is just one where it gives a really high level overview of one of those 4 zones. So you can kind of see like a welcome dashboard and then zoom into one of these different region dashboards. I'll show some of that in the software, but that's just a quick look at their site. So now I'm going to step out from PowerPoint for a minute and show actual Info360. And this is not showing Scottsdale live data. This is a separate site, one of our demo sites. But this is just a quick walkthrough to orient you with what Info360 look and feel is like. So when a user logs in on a web browser, they will come to the dashboard, and this is where users can see the web map. They can get a summary of latest alerts, the alerts by category, new alerts versus high priority alerts versus incidents, and you can step to recent workspaces. You can go to a full web map if you wanted to look at the actual web assets of different isolation valve and different things like that. And you can also navigate to different workspaces. And this is where users can customize any number of different workspaces. We can help configure a few to meet the objectives of your system. So I'm going to click on this one to go into one that is set up for like a pressure system pressure management, which is kind of one of the kind of key objectives for Scottsdale. So really, just like a typical web dashboard, we can set up web maps, graphics, displays. These are fully customizable, so you don't need us to have programmers that program and then it's etched in stone and users can't customize it. Any user can take these. You can duplicate one that we've already created, and then you can zoom in on the data. And in general, once this is up, sifting through the data is really fast. We can, zoom at different time scales, load in quite a bit of data. So these are different pressure sensors. I can highlight the different pressure sensors. I can overlay different alert thresholds or moving averages or other analytics. If I step down, we can also look at gauge charts. So in some cases, operators, rather than looking at a history, they may want to just see at a glance the snapshot of how things are, what's happening at right now, one for each pressure zone, for example. So this shows the latest value and then a peak at the latest 24 hours. We can also look at a long history. This is 3 years of pressure data overlaid with a moving average. So you can kind of see the instantaneous results compared to that moving trend. And here's another example where you can see I think this is just a 15-minute pressure sensor. You can sift along, and as we get to a certain event, the pressure drops down to around 45 psi in this zone. So one of the nice things having all of the data accessible is that when that pressure drops, you can easily lay out these workspaces and have access to other sensors. So where the pressure drops, a pressure drop by itself, we're not really sure exactly what that means. But one of the things that we are doing is calculating out the water usage each hour of the day for each zone. And so here is a look at that water usage for that same pressure zone where this pressure sensor came from. And so corresponding, this is on March 23rd, where that pressure drops, we see a corresponding large jump in water usage on March 23rd. And it's actually happening during the middle of the night. So if I zoom in here, this is right at, it starts right at 2 a.m., kind of anomalously high water usage. And so this would be a pretty high indication that there would be a pipe burst. And indeed, this data actually came from a system where we did have a pipe burst that was recorded. So I'll show where we can step to alerts in just a second. but we can also build patterns here. So this is summer 2018 water usage, where you can see a typical diurnal pattern, but then this is from a different DMA where there's a lot of irrigation at night. So here the pattern actually has most of its flow in the middle of the night, whereas the lowest flows are in the middle of the day. So different zones can vary and seasons can vary. And so pulling out those pattern analytics can be helpful, and we can actually then reference that. So in terms of our alert thresholds. So I'm going to step over real quick to discard my changes and take a look at alerts. So here, a user can sift through different alerts that have occurred. So these are different descriptive names, the priority on which these alerts occurred, and we can also customize the alert criteria. So sometimes alert criteria, it can be a little bit of an ongoing evolution to narrow in on the right criteria, so you don't get too many false positives or false negatives. And so we leave those thresholds open to editing by admin users. So if I go into one of these, this is a pipe burst detection example, just a simple example, and the user can add and subtract different pieces of logic. And so here we have two different thresholds that can be triggered using the water usage that's calculated, as well as the pressure. And we can also wrap that pressure sensor with a moving average. So we could then throw out a simple instantaneous spike in pressure. That might not be something you want to alert on, but maybe you want the moving average. So then if there is a persistent drop in pressure, that could be an indication of a more robust indicator of a break. And we can combine these with and or statements and so on. And we can reference virtual sensors, so you can embed analytics and so on. But one of the good things about these alerts, if I step to one of these, is that the alert is tracked. And so we can see different history of this alert, where it's happened in March, it happened again in May. And rather than just simply having instances where an alert is triggered and then it's something you forget about, we can actually turn an alert into an actual incident. And so an incident is something where it's an event that is being managed. And so this alert is associated with an active incident. So I can jump to that incident here. And so incidents are managed at a separate module within Info360 Insight. And so incidents are where operators and other staff can have a common platform to view the timeline of what is happening with this incident. So you can see the trigger of the initial alert. You can dispatch field inspections where workers can upload attachments of images or associate work orders to third-party CMMS systems. And most importantly, we can also do simulation impact assessments. So if I click on this impact assessment, I'm actually going to step to a different one. Users can have a simple web interface for common workflows to simulate hydraulically what would happen under this incident. So in this case, this was a low flow and low pressure alert that was triggered, and so within the UI we have it set up so that non-modelers can set up a basic handful of parameters to trigger a simulation. And so in this case we have this symbol where the pipe break was established. So that's the pipe break. It's on a certain asset, which is 12708. And in this case, you can define the maximum break flow, and we just insert an emitter coefficient on that pipe from this time of day, which is at 7 a.m. We run it. The user can specify the time period from that time. We take that time, we bring in SCADA data, update tank levels, initial conditions, and so on, pump settings. And then we simulate from 12 hours with that emitter coefficient up to that threshold of flow. And then we simulate how many customers would be affected by that condition. In this case, user can define that as customers are affected if they go below 30 psi for at least 30 minutes. Both those are kind of user configurable with a default setting. So in this case, if I zoom out, We have 2,200 customers, and you can see a heat map of where those customers are affected, which sums up to 648 days of total loss of service hours, which would be pretty detrimental to the utility, because I chose a pretty large water main for this impact assessment. Fortunately, in this case, because it's on a large main, we are pretty likely to be able to detect it using SCADA. If you don't have that, probably a customer might even report it within an hour if it's that magnitude of a pipe break. We can actually also view the pipe break within the animation viewer. So you can, if I click play, you can kind of see a heat map of where and when we have affected customers. So this zone starts to get some supply during this break, but then eventually the storage up in these upper pressure zones start to run out, and we'll see affected customers up there. So that starts to happen in these later hours. So the impact actually evolves over time, and in reality, a utility will be able to start to close off valves before we see all 2,000 customers impacted. So with that, you can actually create new scenarios, and it will detect which valves can be used to isolate that pipe. And you can then close those valves. You can specify a time. It will detect in our asset database if valves are already flagged as inoperable, or if they're already closed or open. We use that. If a user flags it as inoperable in the UI, then it will then trace downstream from there and find the remaining valves that are required to isolate it. But then you can simulate from various isolation events. And so in this case, you can see once we close off those valves, then we only have 86 customers, which are the customers in that one specific closed off pounded area from the valves. And you can download the CSV, get those GIS coordinates, the customer addresses, and any other information that you choose to include in our project shapefile upload that's web mapped. So that's a little bit on that process. Let me see. Yeah, I think that is some of the main walkthrough of the software. I'm going to step back to PowerPoint to finish off. So some of the analytics that we are setting up for Scottsdale include a mass balance for the water usage. And so this is where we just report the water consumption in an hourly time series for each zone that we can isolate, or the total system and the total system. And we can, if we have billing data, we can also include the non-revenue water. If it's hourly, we could do a non-revenue time series. Otherwise, it would just be monthly, just depending on whatever time scale you have for that billing data. And the requirements are flow meters at all main boundaries between the zones, and tank levels with their storage parameters. And so just a quick on the methodology. So like if you have a zone where we have a tank level going up and down, and we have pump stations flowing in and pump stations flowing out, from the UI, we can just drag in those corresponding sensors into our mass balance network. We do simple mathematics, summing up the inflow volumes. For the flow, we integrate the volume over time based on the time steps that you have for your actual flow data. And the outcome is that diurnal time series. This is kind of a pretty foundational thing that you may already have if your system has DMAs, but I know in North America where Scottsdale is, not many have this, or not many have the paring down at this kind of scale. And so where can we set this up? Well, here's just a really simple schematic where we have a pump station here where we have measured flow rate, pressure status, a pump station going out. We have one tank over here where we have measured level. But here we have a PRV going between two zones, and depending on the country where you're in, you may not have any sensors at this PRV. It may just be a simple mechanical PRV. And so in that case, we can't isolate each pressure zone, but we can do a mass balance on the aggregate of those two pressure zones. And so that's one of the things we're going through with Scottsdale. They have 149 different pressure zones, but they have a lot of instances where there are PRVs where we can't isolate. So we are doing mass balance where we lump together zones. And there's a lot of benefits where we can do then leakage reporting, burst analysis on those lumped together zones. And then we can help them identify prioritize locations where adding a flow sensor can then divide up your analytics and get you a lot more value out of what you have. And so the workflow is, this is the UI. Don't need to go into too many details because we can help set this up during our implementation, but there's a UI where it's pretty seamless to just drag in the sensors for the inflows, outflows, and storage and set that up. And then it is generating that time series at like a virtual sensor in real time. A step two outcome of that is that we can do pattern detection. So here we aggregate together the patterns from that data. This is a chart looking at water usage where we overlay the current values, which are orange, against a moving average of the past 2 weeks in dark gray, and the high and the low range from those last 2 weeks. And we can do pattern detection really on any sensor that you have, but where it is of particular value is on the water usage. So that would use the mass balance if we have that available. And there's a pretty simple UI, so we can set this up for your mass balance, but users can customize these different patterns pretty easily using the interface. So another key value is looking at pump efficiency. And so what we can do is we can take the pump sensor data based on what's available, and we can display real-time points of where the pump is operating along its curve. And then the outcome is that the operations and maintenance team can then prioritize pumps with the highest deviation from the manufacturer's curve. And so you can see which pumps are performing the least efficiently, essentially. So the requirements for us to do this on a given pump station, we require a suction pressure, discharge pressure, the total flow rate, the status, a status sensor on each pump, and ideally the pump manufacturer's curve. So just a quick look at what that looks like. So like if this is a pump station with the flow directions, we usually have a suction pressure sensor around there, a discharge pressure sensor. We need the total flow rate. Usually in SCADA, there might be graphs like this that we can generate. And we also need, in this case, like if there's 5 different pumps, we would need then the status sensor for each pump so that we can then use these statuses to filter out the total head difference and flow rates, and then filter out the times when each individual pump is operating by itself so we can isolate individual pump performance. So we don't need pressure or flow on each individual pump. We just need it for the full station, but we do need then the status on each individual pump. And then the outcome is that we can then kind of create a dashboard plotting those the head versus flow for each pump compared to the head difference curve. And so just at a high level view, you can kind of see these 3 pumps are operating pretty much right on the manufacturer's curve. They're doing pretty well. This pump is operating off that curve. So this is kind of just a really simple, poor versus healthy grading that I did. But the methodology is we take those pressure sensors in and out. We take the pressure difference. For our US customers, they're usually in PSI, so we convert it to feet using a simple 2.31 factor. And then we filter out flow rate time series for each individual pump. And then we plot the scatter of those instantaneous values for flow versus head. And then we can compare it with the manufacturer's curve. And we can then potentially take it a step further and turn that into a KPI for each pump. And so what that looks like in a schematic look is for each individual, each pump, each time step that the pump is running alone, we calculate the head difference, and then we look up the total flow from the head curve, from the manufacturer's curve for that amount of head. So that's value X, and then we compare that to the actual measured flow, and then we can come up with an efficiency coefficient. And so, like for instance, for this point, that might be, for example, 91.3% that the of the hypothetical manufacturer's flow for that head difference that the pump is actually delivering. And so that 91.3%, that's one value. We could really generate a time series of many different values as that pump is operating at different points in time, come up with a moving average time series, and then you can compare that across pumps, and you can see which pumps are the farthest off the curve versus others. All right, and we can also do break impact assessment. I showed a little bit of this in the software, but ultimately, once we have your model connected to SCADA, we can set up those dashboards. And the requirements of that is we really just need an up-to-date hydraulic model of the system, and having the SCADA integrated is a key step in getting the model up to date. And then we also need the customer location points, as well as the isolation valve locations. And for InfoWater Pro users, we don't need those valves to be in the model. We can just use GIS points, and then we associate it with the nearest pipe, and then we close that corresponding pipe. And so this is a little look at that workflow for users. I kind of already showed that in the software, so I'm going to skip past that in the interest of time. I'm noticing that we have 12 minutes left. So then the final piece is integrating the hydraulic model, which was kind of a key driver for this for Scottsdale. And so the flow of data goes both ways. So we can take your InfoWater Pro model and we can publish it to Info360. We can use that to generate the web map of model objects. We can also incorporate the customer and valves. We also can use the model for your designated scenario to do easy simulation management, or incident management simulations. But we can also take that data from Info360, pulling real-time SCADA. We can pre-process that SCADA to kind of clean it up, and then we can bring that back to the model for on-demand initial conditions. We can take that mass balance water usage profiles, create those patterns that I showed earlier, and bring those directly into the model for the process demands. And then there's also then a gap analysis dashboard, so that once you choose to run a SCADA run for any event, like let's say we wanted to run the model for yesterday, you just input that date, run the model, and then you'll get a dashboard for how your model compares against the SCADA data for that date time, incorporating initial conditions, the demands, and in upcoming feature development, we're looking to bring over all of the pump control time series and so on. So this is just a simple look at InfoWater Pro. For that model we were looking at in the web, we now have this icon to upload those different web layers to the cloud version, incorporating the valve status, the valve state, the customer elevation points, and so on. And here is our live data adapter tool, where you can then jump to a dashboard so that a user can get a quick range of statistics for how well the model is comparing against SCADA. You can customize color categories for how the model is comparing. This example is not a well-calibrated model, but it's just an example. So this graph shows the difference between model and measurement in terms of flow, and then you can also drill into individual graphs, and it's all an interactive dashboard, so you can sift through, pick which ones you want to compare against. It's a floating window, so you can put this on a separate monitor while you're looking at your model, and so on. So we're doing a lot of work right now in InfoWater to really streamline the calibration of models now that you have Info360 SCADA data, and that has been kind of a key workflow that our users get hung up on is ease of calibration, because it can be a challenging process. So what are the benefits of improving that calibration process and actually keeping a water model current? We have one of our users we did a webinar on a year ago, where they're actually doing bi-weekly model validation against SCADA. So they're actually keeping their model validated to SCADA on a regular basis. So anytime operations asks the model a certain question, they have confidence that their model is up to date. And so how do we do that? Well, you have to update the model facilities from GIS, allocate demand spatially, bring in those demand diurnal curves, update your pump curves, update the controls from SCADA, and then actually do the calibration and employ user modeling expertise to know what parameters need to be changed. This is what is needed to be done to keep the model current. These two functionalities are embedded into the InfoWater Pro workflows using GIS integration, but the rest of these are SCADA integration. Typically, takes a while with conventional approaches, but with Info360 that's streamlined. And then some of the benefits of having that integration is with Info360 plus InfoWater, you can respond quickly, confidently to performance changes. You can provide insights to operational responses, supporting decisions with evidence rather than just kind of anecdotal, anecdotal evidence. You can also do water quality assessments once your model is reliable. You can understand system behavior between gaps in sensors. So you can't deploy a sensor at every single location. That could be cost prohibitive, but once your model matches those sensors that you do have, you can then trust the model in between the sensors with some more confidence, and really keeping the model up to date on a regular basis really can reduce the upfront costs on master plans. So this is money you often are needing to spend anyways in the long run. So keeping the model up to date in the current time and shaving off that time really helps you benefit with all these other things in between. And so that is just a high level benefit. So I think now we're going to hand it over to questions. So yeah, great time to submit your questions if you haven't already.
Thank you very much for presenting to us what Info360 looks and feels like with the different examples of the workspaces. We have seen uses such as calculating mass balances for water usage, looking into pump efficiencies, pattern detection, assessing the impact of incidents, and hydraulic model integration. I think we will just open the floor for questions. Again, please send them using the Q&A function in Zoom. We already have quite a few questions there. So we'll just do a very brief pause and we'll start the question period.
Okay, well, yeah, I think I can jump into some of these questions and I'll we'll just hop into these.
You want to choose which questions you want to go for?
Yeah, sure. I'll start with.
Or would you like me to just present them to you and you can choose which ones?
I think I can pick out questions. So I'll introduce it, read the question, and then give it a quick answer. John, were there any that you noticed that you want to make sure that we get to?
Yeah,
you want to call out?
There was a really good question, actually, and I think it's a really common one about the sensor data beyond SCADA sensors and the plan to deploy additional sensors, and if so, what brand and type. I really want to touch this question because I think it's important. A lot of the customers we work with, if not every customer, no one has the perfect sensor placement, for example. I think Nathan even mentioned that in terms of defining each pressure zone for Scottsdale. So, we fully understand that. And as Nathan mentioned, this is somewhat of an iterative process where there's a lot of different options. You can start with one pressure zone, your most defined pressure zone, or one that's, the top concern. And then you can use Info360 Insight and InfoWater Pro to even determine where to place that next sensor. So we very rarely work with folks that are, just, hey, here's our sensor placement, here's our model, we're ready to go. So it's always a process, and there's always, future investments that can be made that, using this data to kind of make those decisions. And in terms of the types of sensors and brands, we're really not concerned about that. We're more concerned about the data. and where the data lives. So we're really concerned about where that data is being stored in terms of what database it's being stored on or what type of database. So from a hardware standpoint, we really do not care. We only care that it's being collected in a time series fashion. That's really the only requirement for Insight, is that you're collecting data in a time series fashion so that we can consume it. I know there was a question similar to that. So yeah, just want to answer that question. It's really a process to kind of, build this out for your entire system.
Thank you very much, John. If I may, I just, if you don't mind, I'll go through them. And so I'll just mention who's asking the question so we can all have that information as well. It might be interesting for the discussion.
Okay.
So we had a question from Binas Kabas. That's a little bit difficult for me to pronounce. Lead hydraulic engineer at EN Inc. And he said, besides Info360 and InfoWater, what are the things a utility company needs to have in order to be able to use this service?
Yeah, good question. Thank you, Benaz. So we don't actually require InfoWater or InfoWorks WS Pro. Info360 Insight is the specific module that we were presenting today, and that does require some sort of time series data is really what it uses, and we can connect to any number of different sets of time series data that you have. Usually, Water Network SCADA is the most common, but we do have upcoming a bit of upcoming functionality to support sewer collection sensor data, and so. Yeah, just sensor data. And there's also other Info360 modules that will focus on asset management that won't require SCADA. As far as the model, we can integrate directly with InfoWater Pro or InfoWorks WS Pro. But if you have another type of software, we could certainly look at using a simple EPA Net model upload, for that incident manager workflow, and we can work with you on that.
Okay, thank you very much, Nathan. We have a question from Athryn Gerber, civil engineer, system planning at Tucson Water. Do you typically use sensor data beyond the SCADA sensors? Is the plan to deploy additional sensors? If so, what brand or type?
Yeah, and that was the one I just answered for Catherine at Tucson. Okay. And the one thing I'll add is we do, I mentioned earlier, we can use any live data really that's being collected on your distribution system. I'd say the next most common one, but beyond SCADA data, is your consumption data. So if you have any like AMI readings that you're collecting in the field, a lot of customers want to utilize that data. In our case, we can use it for that water loss calculation. So typically we use minimum nightly flow. This is getting a little deep into the weeds, but we can use the actual consumption data to get a little bit more granular and accurate in terms of that baseline for our water loss calculation. So yeah, anything you want to add to that one, Nathan?
Nope. Yep. That's good.
Good.
Okay. Thank you very much. So we move on to the next one. This one is from Elena Bronix from Bohannon, Houston, Inc. Where are the pressure sensors located, and how were those locations determined? On the mass balance, are those main meters from wells and or from customer meters?
Yeah, well, we often see pressures within within a zone or a DMA. There may be a pressure at certain high elevation points within a zone. Usually, always at tanks and often downstream of pump stations, but we can really use your existing sensor locations. We may offer some recommendations on additional sensor locations that would be beneficial, but we usually work with what you have and help you understand the I don't know, any caveats with that. As far as the mass balance, we often are just using whatever flow sensors that we have between zones. So if you have it on valves, pump stations, that's great. Yeah, usually at wells where they're pumping out of the ground into the zone, those are important to have. And then as for customer meters, those are optional. Those are great to have. If we do have the customer meters, then we can do the mass balance where we're actually directly calculating out the non-revenue water from the zone. But if not, we then just get an aggregated total water usage that's going into the zone and not being passed to another zone. And so that's really the total revenue and non-revenue water coming out of the zone.
Okay, thank you very much, Nathan. So the next question would be from Sean Dent, VP at Carollo Engineers. Can you show overlaying a GIS file so you can see the pipes as a background layer in the map views?
Yes, yeah. I didn't. I showed briefly the map, and yes, we do upload the pipe location, so you can see the pipes and other assets that you choose to provide us. We're also working on being able to embed any kind of web map service on the background. Currently we store the files ourselves in our cloud, and you can toggle between those different locations. But yes, the pipes can be displayed map views.
Perfect. So the next one is from Russell De Castro, a hydraulic modeler. And it is, so does that mean any valve that you close is actually closing in the hydraulic model while the results get back to the Info360 platform?
Yeah, I assume this is referring to that incident manager module in the web interface that I was looking at. And so, yeah, what happens in that case is we close the user can close valves, and those valves are closed in that single instance of the model. So we simulate with all those valves closed, but it does not tie back to our asset database of the valves or back to the actual hydraulic model. It's just a temporary closing of the valve for that one analysis.
Okay, thank you very much. Next one from Susan Nipper, engineer at OHM Advisors. Can the software deal with adjusting timestamps? For example, if you have two different sources of SCADA data that would be needed for mass balance, but one is recorded in standard time and one is in daylight savings time.
Yes, for each of your sources of data, we configure in the time zone that your data is coming from. And then on the back end, we store all data actually in UTC time, but the user in the web dashboard can choose what time zone to assign for the whole system. And so that is used. And so that's how we can combine different time zone. And as far as time stamps, we do some sampling of the data. So we take whatever interval your data is coming at, even if it's irregular intervals, at 2:47 and 36 seconds and then 2:49, we sample it into, for example, 5-minute increments. So we can then store the open, high, low, close, and average values of each of those intervals. And that's how we can easily deploy analytics where all of the data is synced up. So we can do analytics on time steps in a really easy, accessible way.
Okay, thank you, Nathan. We're making you work a lot here with this question.
That's good.
I'm trying to answer some of them, sorry, through typing. So
sorry.
Yeah. Thank you.
From Tahira Jasmine, Water and Wastewater Senior Engineer. Is Info360 working independently or does it require InfoWater, InfoWorks?
It can certainly work independently if there are a number of use cases that don't require a hydraulic model. If you wanted to just do sensor alerting and dashboards, you can certainly do that.
Okay, thank you. Another question from Carmen de Miguel, strategic marketing manager at Schneider Electric. Any specific analytics for urban drainage catchment management?
Oh, sorry. Can you repeat the question? I was expecting a different question.
He's asking if there are any specific analytics for urban drainage catchment management.
Not in the current release. Our initial, we released the software earlier this year, and the current target is water distribution systems, but urban catchment analytics for sewer collection systems is certainly coming in the near term.
Okay, thank you. Another question from Carlos Lopez, water engineer at Atlantica. If 2 or more pumps are running at the same time, you should either need an individual PIT or FIT to know if the pump is running good or not. What if one individual discharge valve is more closed than other?
Let's see. I am not sure I understand this question.
Okay, we might skip this one, and maybe Carlos, we ask you to please rephrase it and type it back again in the Q&A box, and we'll try to come back to it later. And we'll go to another question. Glauco from Brazil, working in Schneider Electric too. On the platform demonstrated, is it possible to trace contaminants in the piping? For example, high levels of chlorine. In case of incidents, is it possible for the platform to send service orders to the maintenance team via other customer software, e.g. SAP? Is the platform sold with all the features presented, or can it be sold in modules?
Yeah, good question. So at the moment, we would leverage our hydraulic models to do those water quality simulations and tracing, and so you could bring your SCADA initial conditions to the model to simulate from there. I know that our IW Live modeling software can run continuous water quality simulations to keep that traced. But that would be the workflow. And at the moment, the water model results don't go back to the dashboards, but that could be configured with IW Live. They can be configured to do that. As far as then pushing out the software to other service orders and maintenance teams. So we are certainly working on APIs to be able to exchange with a growing number of other platforms. That is certainly the intent of us being now in a cloud environment where we can set up those APIs. At the moment, we don't do that specific one, but that's definitely a priority in our roadmap is growing those APIs to connect with other platforms.
Okay, thank you. Now, Tanya Marquez sends more of a comment. She says, great case. One problem we used to face is how to justify to the board the investments on such a project. Maybe you can share some ideas on that.
Yeah. We one of the takeaways from Info360 is we can report non-revenue water per zone, and so that can be an indicator where investments need to be done, or acoustic surveys to locate breaks. But we also can leverage dashboards for the pump performance to target pump improvements. And one of the other things is that once you have a dashboard where you're tracking performance and KPIs, then when you do improvements, you can then also show a timeline of the actual measured performance increases. And so having these dashboards and the transparency helps you justify the projects, and it also helps you get visualization on the actual benefits of the projects to give feedback for more projects or maybe a different type of project. And so, yeah, this is a great benefit for board management and so on.
Okay, perfect. Thank you. Next question is from Eric Bones. Is the data one way coming out of SCADA? Is it possible to integrate data DMZ?
Yes, at the moment, right now, the data flow is purely from SCADA and into our platform, and our intent is to provide insights. We don't provide controls back to any kind of SCADA system And so, yeah, right now it's a one-way up to our cloud, and then we provide the staff with insights to, possibly operate things, but it is up to operators and staff to implement any recommendations from our software.
Okay, thank you. Next question from Catherine Gerber. With sensor data, do the databases need to be combined, or can you use separate time series database data from separate sources, such as one database for SCADA, operational sensors, and another database for additional planning sensors, and maybe a third? And she says CIS or WMMS.
Yeah, sorry, Nathan, I plopped an answer in there for that one. Yeah, it does not matter if it's in different databases or different sources. That's where we're using the data ingester to consolidate basically different data sources if that's the case. And actually, that's more commonly the case, I would say. So yeah, that's not a problem. We can pull from different databases, and that's what the ingester's for, to consolidate it and then send it up to our platform in a very encrypted, secure manner. Anything you want to add to that, Nathan?
Yeah, and once we have our data ingester deployed on premise, admin users can actually use the web interface to configure additional data sources. And so then, you can actually add more databases if you have like SQL servers or things that are easy to connect to, and you don't even actually need our assistants to connect those for you. So yeah, it's pretty open.
Okay, thank you both. A question from Homero Garza, Data Systems Manager at the City of Fort Worth Water. What are the costs associated with data transfer from an organization to the cloud environment? And he has a second question, what are the requirements to view the dashboards? And he also asks about licensing.
Yeah, I'll take this one, Nathan. So there's not really a cost associated with the data transfer. So this platform is a subscription-based platform. So even a utility has the opportunity to turn it on and off if they really wanted to on an annual basis. But everything's inclusive in that subscription. So everything from the data ingester to obviously the data transfer, all the way through the online platform and the dashboards itself. So yeah, everything's included within that subscription cost. And it's the one thing I do want to mention, just to reiterate, it's an enterprise platform. So there's no limit to the number of users. There's no limit to the number of dashboards, alerts, or anything that each user wants to set up. So it's really just a straight subscription fee for your entire organization. That's all inclusive. And then, as Nathan mentioned, we typically include implementation services, whether that's from us or one of our consulting partners. So that's, kind of a separate custom discussion, I guess, for lack of a better word. But in terms of the Innovyze product, it's just a straight subscription fee. Anything you want to add to that, Nathan?
Yeah, just that the subscription varies by the number of sensors. I thought I said if you're a smaller utility, it's a lower subscription than if you have tens of thousands of sensors, for example, just because of the cloud costs on our end, obviously.
Okay, thank you both. And we have a question from Carlos Garcia, a staff water engineer at Arcadis. You mentioned resampling data. If the interval is larger than the resample, how is the data interpolated? Is billing data also interpolated to perform mass balances?
The user has the option as we're configuring the sensors. You can choose either no interpolation. So if there's a gap, if there's like a gap in data, we could treat that as a null. Otherwise, you could say extend the last known value. So we could just keep using the last value, or you can use linear interpolation. Those are currently the options. As for billing data, so this is specifically on the time step. So if you have like monthly, could we interpolate that for a daily interval? I believe so, but I am not sure. I haven't actually worked with the billing data on that, but I would believe so. Sorry for a vague response on that.
Yeah.
Okay, thank you very much, Nathan. So now just one more general question. So how is Info360 Insight different than a SCADA software solution?
I'll start with this, Nathan. One of the things I mentioned at the beginning is a lot of folks have a SCADA system already, which of course comes with hardware and a lot of times software. Those are a lot of those systems have come a long way in terms of being able to do analytics, but I would say that's really the key difference with our platform is, we're not looking to replace your SCADA system, of course. I think it's pretty clear that we're leveraging SCADA data. So really the main point of this platform is to perform analytics on that data so that you can open it up for, again, all the members of your organization. Typically SCADA data is quote unquote raw data. So that's where as a water focused company, we've taken our expertise from an engineering and modeling standpoint and put it, into a platform that can be used for operations as well. So it's really processing the data so that we can use it for operations, for management, for planning and engineering, really just to open up that data. And we all use the word silos a lot. I know it's very cliche, but that's really what we're trying to do here is kind of open things up from a live data standpoint to the entire organization. Anything you want to add, Nathan?
Yep. That's a good summary.
Okay, thank you very much, John. Another more general question too about security. How is Innovise ensuring that data is secure?
Yeah, I'll take this at a high level. I think we check a lot of the boxes because we built this platform with Amazon, so we do leverage a lot of the data security that Amazon offers just right off the bat as one of kind of the leaders from a cloud services data standpoint. So yeah, we everything is encrypted. Everything. We meet every technical requirement that we've come across in terms of SOC 2 requirements. That's probably the most common one I've seen in the States. I know there's different IT requirements depending on where you are in the world. But the bottom line is that we work with major customers. I think we stated that at the beginning in terms of our client base. So everybody has different IT requirements that we understand that. And I personally have been a part of quite a few meetings with IT folks to discuss data security. Like Nathan mentioned, it's a priority. We understand that. We've seen everything else in the news everybody else has seen. So we are very aware and very focused on data security. And we have a cloud services data security team that is happy to meet with your IT team to discuss some of the specifics. Our cloud IT guy could probably sit on here and run through some of the specifics from a technical standpoint for about an hour. I've seen him do it before. But the bottom line is, that is top of mind here at Innovise, and data security is really the priority with this platform. Anything you want to add to that, Nathan?
Yeah. I think utilities are starting to come around to the idea that the cloud is actually in many cases more secure than on-premise data. And we have a tight partnership with Amazon, which, using the best in class web security, and we can provide technical papers on how we achieve that for anyone interested.
Okay. Thank you both. Another question about Info360 Insight. How does it connect to Innovice's hydraulic modeling solutions?
So if you have desktop modeling solutions, which is actually all there is at the moment, we have a direct APIs with the model, so the model can pull Info360 data to the model. You can upload the model to the web. And at the moment, we are building more and more model data and model engines in the cloud to leverage cloud computing. So that is upcoming in the future. But at the moment, if you have an on-premise, Info Water Pro or InfoWorks WS Pro, you can bring SCADA data through. And that can inform your initial conditions as well as the demand variations and control patterns.
Thank you, Nathan. Another question is, what if my distribution network does not have expansive SCADA coverage?
Sorry, Nathan. I think we've answered that one a couple times, but the one thing I want to add to what I've already mentioned is, correct me if I'm wrong, Nathan, there's also ways you use the word virtual sensor. So again, we understand you might not have a sensor in every single place that you need to define a zone, for example. So there are ways to kind of hard enter like a baseline into the software as well, or quote unquote, use a virtual sensor. So again, we fully understand not everybody has the hardware or infrastructure to roll something like Info360 inside out to the entire network. So yeah, there's a lot of different options, whether it's virtual sensors, putting a sensor there in the future, whatever it is to kind of help, complete that initiative or journey to making it an entire covered network, I guess, where you can leverage the tool for the entire network. Anything you want to add, Nathan?
Yeah, we can have discussions with utilities based on what they have and what their objectives are and what the data requirements are. So wherever you're at, but usually what we have found is that whoever gets Info360, it usually does help point out spots where like wow, if I had a flow rate sensor right here, I'd be able to get this additional value. So it does usually highlight additional places where you're going to want sensors, and so it can help give that some of that guidance actually.
Okay, thank you very much both. This has been a very interesting discussion, and as we're getting close to the end of the webinar, I would like to ask you a question for both of you, if you can both answer it. It's taking into account everything that we have discussed today. How do you see water management 20 years from now?
Wow, that's I wasn't ready for that question. You want to go first, Nathan?
Yeah, sure. Yeah, we see definitely a wave in digital transformation among IT groups where things are just much becoming more cloud integrated and streamlined. And so we see hydraulic modeling has typically been sitting mostly in the planning side of organizations. But as it becomes cloud enabled with the right user interfaces, simulation-based insights can really help out the broader organization. So we see models being brought into a more central place into data integrated analytics to support operations, easier use for planning engineers. And so I think the future is bright, really being supported by a digital twin where the model, rather than just being a desktop standalone copy, can truly live in an integrated environment where we can have services that integrate it with SCADA, GIS, and other pieces that can keep that model up to date, accurately representing the current state to support system diagnostics, forecasting, and so on. So there's a lot of benefits once we can overcome some of these technical hurdles that we're jumping, that we are overcoming now. So yeah, a bright future, definitely.
Yeah, I'll echo everything Nathan said. He hit it kind of on the money. The one comment I'll add is, to be honest, I think our industry is behind in terms of innovation. This is such an important industry in terms of delivering clean water, to residents, and it's so important. But when you look at other industries, take a warehouse, for example, a Walmart warehouse, for example, everything's automated. Everything's, very live and maybe even predictive. So it's really, the new technology, I would say, whether it's from Innovyze or another vendor. I'm excited to kind of see the transformation that Nathan's referring to, because I really do think we're kind of just at the beginning, kind of at the cusp of utilities kind of going through that digital transformation. And it's a very long journey. But I'm really, excited kind of thinking about the finished product or the future here where everything is a lot more integrated. Everything's a lot more live, a lot more automated, and hopefully a lot more efficient. That's really the idea here is make everything more efficient, make everything the highest level of service possible. So that's where I think leveraging technology can definitely increase those initiatives. So yeah, that'd be my answer for that question.
Okay, thank you very much both for this answer. And I think we're now going to get to the end because it's now almost an hour and a half since we started. It's been a very interesting webinar. I think there might be maybe a few other questions, but we encourage those people to contact you directly if they wish to further clarify anything. And so we'll forward those questions to the speakers. Okay.
Yeah, that'd be great. We'll reach out to. I saw a couple folks that were asking for like the local representative, so we'll be sure to follow up with anybody that left a comment like that.
Perfect. Thank you very much, John. So I would just like to thank our speakers today and everyone attending the event. And just remind you that the event has been recorded, and so you will be able to watch it if you want to in the website of Smart Water Magazine.
Thanks for having us, Christina. We really appreciate it, and thank you for everybody who attended. I know we went over, so thank you for everyone's time. We appreciate it.